Hello, everyone, and welcome to another episode of What's Up with the Universe. Well, today we are going to be asking, well, what's up with the universe? Mars, yes. Welcome, everybody. And I apologize for that intro. I had an extra tab open. That's why you heard the little sector countdown. The sound was kind of odd, so I apologize, everybody, at the beginning of this stream here. Yes, welcome to a very special stream, man. First of all, I want to welcome people who are already in the chat right now. Jedi Bill. Excuse me. You are second again. Well, technically, you're first. Excuse me. Yes, you are a Sith Lord, of course. Welcome, Bio Mike. Who else is here? Let's see. Who all is here? We have Thomas Potts. Professor Bernie Specs. Welcome. We have Positive Kendor. Welcome, dude. Welcome, everybody. Let's see who else is hanging around here right now. Mountains of Elysium. How can I forget you, man? What's up? We have a very special show today because today is Perseverance is landing on Mars. Yes, it is. And we have a special guest today. You may have followed her or seen some of her streams, but we are going to. I'm going to introduce you to a special guest today. Her name is Andrea. Yes, you may know her. Andrea Seabrook, yes. Well, she's currently right now is doing a little work for her salmon, cooking salmon, helping her father out. So she'll be joining us in a few minutes. Cool little picture. Thank you, Garrett Head. Okay, let's get on. Let's get on talking to Mars here. Okay. Where's my Mars? There's Mars. Okay. Today, it is the countdown to Mars. Yes, it is. Mars, the red planet. It is the fourth planet from our sun. Yes. It is also known to be in the habitable zone of our solar system. If any alien civilization was to look upon our solar system, they would see three planets in the habitable zone: Venus, Earth, and Mars. Just because a planet is in the habitable zone does not necessarily mean it has active life on it. This is what Perseverance is trying to prove today. It's going to get a whole new, great new rover, which I will get into in a little bit. It has some great cameras and a very unique landing system. Yes, I'm going to talk about this. It's a first of its kind. Mars. Sorry, on. This large canyon right here. This is called. What's the memory called? Sorry. This is called the Valles Marineris. Yes, Valles Marineris. I was talking about earlier that it's long enough to stretch from California to New York. It's more than 3,000 miles long. This canyon is about 200 miles at its widest and about 4.5 miles at its deepest. Of course, that's 10 times the size of Earth's Grand Canyon. In this picture right here, you can see there are three visible volcanoes. These are known as the Therias volcanoes, the dark red spots. These are about 25 kilometers high. They're called the Acrisius Mons, the Pavonius Mons, and the Arceria Mons. Arceria Mons. Yeah, sorry about that. Wow. Okay, that's kind of odd. I actually see my little Wi-Fi connection, so that's kind of weird. Sorry, that's a little new for StreamYard for me. Like I said, Mars is the fourth planet from our solar system. It has 2 moons. I'm sorry, I'm getting ahead of myself here. It has about a radius of about 2,106 miles. It's about half the size of Earth. And if the Earth was the size of nickel, Mars would be about the size of a grape. That's about how small it is. The orbital rotation. As Mars orbits the sun, it completes a rotation about every 24.5 hours, which is similar to 1 day on Earth. Martian days are called sols, short for solar days. A year on Mars is 669.6 sols, which is the same as 687 Earth days. I mean, Mars' rotation, the axis of rotation, is tilted about 25 degrees with respect to the planet of the orbit around the sun. It is very similar to Earth, which tilts at 23.4 degrees. Springtime for Mars is a little bit different than Earth because Mars has 4 seasons. Yes, just like Earth, Mars has 4 seasons. Springtime on Mars is in the northern hemisphere, and autumn is in the southern as the longest season at 194 sols. I mean, autumn in the northern, spring in the southern, it's the shortest is about 142, 143 days. That's very short. Let me explain how long a sol is, okay? A sol is 1 Martian day, and 1 full rotation of Mars from the perspective of the sun is approximately 88,775.2449 seconds, or 24 hours, 39 minutes, and 35.5 seconds. Slightly variable due to the orbital eccentricity. The structure of Mars. What's it made of? Well, simple. Mars is a rocky planet. Its solid surface has been altered by volcanoes, impacts, winds, and earthquakes. Sorry, Mars quakes. Yes, Mars has quakes. Of course, it has a dense core at its center, between about 900 and 1,500 miles in radius. It's made of iron, nickel, and sulfur. Surrounding the core is a rocky mantle between 770 and 1,1,200 miles. It's thick, and above that is a crust made of iron, magnesium, aluminum, calcium, and potassium. Yeah, wait. Yes, okay. Iron, magnesium, aluminum, calcium, potassium. The crust is only about 6 to 30 miles deep. So, the surface of Mars. What is on the surface of Mars? Dry. It's known as the red planet. People call it the red planet because it's the iron minerals in the Martian soil oxidize, or basically they rust, causing the soil and atmosphere to look red. The red planet is actually many, many different colors besides red. Of course, as you can see in the picture here, we see the surface of the colors, such as brown and gold and tan. The reason Mars looks so oxidized is because of the regolith, is the Martian soil, as the dust of Mars. It gets kicked up in the atmosphere, and from then, the distance goes around the planet and makes it almost entirely red during the heavy spring wind time. Of course, interestingly, the helicopter is of Krogan design. Oh wait, but no, the helicopter is not a Krogan design. Those damn Krogans. What? Okay, Professor Berniak Speck says, why are spring-autumn durations different for the different hemispheres? I thought I just covered that. I'm sorry. I did. I apologize. I did not get into the chat though. Sorry. I have too many tabs open up because today is very exciting for me. We get to go to Mars again. Eli, the high science guy. So high. Okay. Well, yeah, talking about high and up in the sky, we're talking about Mars. Interestingly, while Mars is about half the diameter of Earth, its surface is nearly the same area as Earth's dry land. I mean, there's volcanoes, the impact craters, the Mars quakes, the dust storms. They all have different geological impacts on the surface of the planet. And since the geological surface is a little bit different, we have a huge volcano on Mars called Olympus Mons. Yeah. Here, check this out. Olympus Mons. It's home to the world's largest volcano in our solar system. It's 3 times taller than Earth's Mount Everest, with the base the size of the state of Arizona. Can you believe that? It's about this big. I mean, of course, you got to realize this. Mars does appear to have a watery past. Scientists have actually confirmed this because when they Curiosity scraped on the surface of Mars, they found liquid ice, and they took another picture, and it disappeared, which means it melted. There is water on Mars. Yes. The atmosphere of Mars. It's a little bit different. It has a very, very thin atmosphere. It's mostly. See, once again, I cannot talk. It's mostly. Excuse me for a second. It's mostly made of CO2. Argon, nitrogen, and just a small amount of oxygen and water in the atmosphere. To our eyes, as you can see in the picture here, the sky would be hazy red because of the suspended dust instead of the familiar blue thing that we see on Earth. Excuse me. Mars is very thin atmosphere, doesn't offer much protection from the impacts such as meteorites, asteroids, comets, solar radiation. Of course, it can be a nice day on Mars because the highest records recorded was about 70 degrees Fahrenheit. Yes, a nice warm day in Florida right now. Lucky Floridians. Yes, it did. It had a magnetic field like ours once. Are we getting this 11 minutes late? Maybe. I'm sorry. I'm waiting for Andrea to come back here. This right here is called a Martian sunset. Yes. Occasionally, the winds are strong enough to create dust storms that will hue the horizon to make it look like a sunset on Mars is blue. Yes. This is the actual visual spectacle image. Basically means what your eye is seeing. Yes, because I think Total Recall was correct. There is a blue sky on Mars. Like you were saying earlier, the magnetosphere. There was once a magnetic field like our own on Earth here. It's basically it's a shield that prevents charged particles from reaching our planet's surface. Since the particle is born by the solar wind throughout the solar system, they are typically electrically charged. The magnetosphere acts as a protective shield against all these solar winds here. But of course, Mars right now has no global magnetic field because it's very sporadic. But areas of Martian crust in the southern hemisphere are highly magnetized, indicating traces of a magnetic field from approximately 4 billion years ago. Of course, like I was talking about earlier, Mars has 2 moons, Phobos and Deimos. Phobos. There may not be actual moons, but maybe captured asteroids. Oh my goodness, any way we can prevent this? Restabilize the magnetic core of Mars, maybe? I'm not exactly sure. I'm not a thermodynamic expert. Yes, that is partially true, Vile Mike. Mars does have a sporadic magnetic field, but not stable for Earth, for Earthlings. Well, we can actually go down to the lava tubes and the caves, which that can offer some protection, but that is kind of highly likely. Oh, and sorry, I just have to say this real fast. Before I get any further, I want to wish Mr. CCDV
happy birthday to you. Happy birthday to you. Happy birthday to you. Happy birthday to you. Happy birthday. Happy birthday.
So I had to wish Mr. CCDV happy birthday. So hey, I know he's not in here, but I just have to do that publicly. Hey, he's a cool dude, the drunken philosopher. Check him out. Check him out. He's pretty cool. He's a good cook too. He has some good cooking videos. Yes, thank you. Thank you, Gert Geeson during the erotica. Happy birthday, Mr. CCTV. Happy mention. What were we talking about? Oh, yeah, we were talking about Phobos. And guess what? Andrea's still not back because I still did not see her on camera. Huh. Okay, well, I guess we'll talk about Phobos behind her back. It's the innermost and largest moon. Seen here by the reconnaissance orbiter in 2008. It is heavily cratered with deep grooves on its surfaces. I mean, it's slowly moving toward Mars, and they estimate that it crashed or either break apart in about 50 million years. Deimos, the next moon. It is basically about half as big as Phobos and orbits 2.5 times farther away from Mars. The oddly shaped Demios is covered in loose dirt that often fills with the craters on the surfaces, making it appear smoother than pockmarked Phobos. I mean, these color-enhanced images of Deimos, it's one of the smaller moons here. This was taken on February 21st, 2009. And, of course, there are very many missions to Mars that have been in the past. And one that's happening right now as we speak is Perseverance landing. Yes, I'm excited for this. The Perseverance landing. There have been Phoenix, Viking 1, Pathfinder Opportunity, Viking 2, Insight, Curiosity, and Spirit. And as you can see on the map, this is the approximate area that Perseverance will be landing in. The reason why I said approximate area is because of the unique landing cameras that they have on here on the bottom of the rover. These are some of the main functions that the rover has. The Moxie, the Rimax, the Master Z-Cam, the SuperCam, the EDR, Sherlock, the Philix, P-I-X-L, however you want to pronounce it. The Mass Cam. Yes, see that little guy in the upper corner? His name is James Bell. He's the principal investigator from ASU in Tempe. The Mastcam Z is an advanced camera system with panoramic and stereoscopic imaging. Oh, I wish I could just acronym that for you guys, but I want you to understand what this camera does. It has the capability to zoom. Yes, the instrument will also determine mineralogy of the Martian surface and assist with rover operations. This next image right here, this dude, his name is Jose Rodriguez Manfredi. He's the principal investigator from Centro de Astrobiological Institute, Nacional de Tecnicia Aeroespacial in Spain. He is responsible for the MEDA, the Mars Environmental Dynamics Analyzer. This is a set of sensors that will provide measurements of temperature, wind speed and direction, pressure, relative humidity, and dust size and shape. The next person you see right here, his name is Michael Hetch. He's the principal investigator from MIT. He is responsible for the Mars Oxygen ISRU experiment. This is an exploratory technology investigation that will produce oxygen from Martian atmospheric carbon dioxide. Yes, this is why I'm so excited for this mission right here. The next mug you see just happens to be, what's her name again? Sorry, Abigail Alwood. Yeah, Abigail Alwood. She is the principal investigator from JPL. She's responsible for the PIXL, the Planetary Instrument for X-ray Electrochemistry. This is an X-ray fluorescence spectrometer that would also contain an imager with high resolution to determine the fine-scale elemental composition of the Martian surface materials. It will analyze it, basically, even a lot more than any other pros have. And guess what? We have our special guest here. We have Andrea.
Hi. How is everyone?
Good.
Excellent. Glad to be here. Oh, that is a very exciting looking bot you have there. What is that?
Oh, that is the PIXL. It's by Abigail Alwood from JPL.
Awesome.
This has helped determine the composition of the Martian soil itself.
Awesome. I'm excited. Have you already shown a picture of what the actual Perseverance lander looks like?
Yes, I have, and I've got some more of it for you.
Awesome.
I just got a couple more little instruments I want to tell people about. What's on Perseverance?
Okay, let me be quiet. Go.
Oh, come on. Well, we also have on the instrument here the RIMFX, the radar imager for Mars substance experiments. This is by Sven Erik Hammerén from Norway. The Forsevets. Okay, I'm sorry, Mr. Hammerén. I'm gonna pronounce this or mispronounce this. The Forsevetis Forskningsinstitut in Norway. I told you I'm going to mispronounce this. I'm sorry, Sven.
No,
okay, I want to give you credit, man.
That's too hard. It's too hard.
Well, the instrument right here, it's a ground-penetrating radar that's going to provide centimeter-scale resolution of the geological structure of the subsurface of Mars, which will kind of help determine how actually quakes and probably help us on Earth to predict them.
Cool.
Detective, kind of like Sherlock, the scanning habitable environmental with Raman and luminescence for organic and chemicals. This guy right here is Luther Beagle from JPL. This right here has a spectrometer that's going to provide fine-scale imaging and use a UV laser, ultraviolet. That's going to provide fine-scale imaging and for detecting organic compounds. It's going to be the first UV spectrometer on Mars.
So cool.
Yeah, but how about this one? The SuperCam.
SuperCam.
SuperCam by Roger Weems.
Woo!
Yes, from Roger Weems from Los Alamos National Laboratory in New Mexico. Yes, great in technology there. The SuperCam. This is an instrument that can provide imaging, chemical composition analysis, and mineralogy. This will be able to also detect the presence of, get this, organic compounds in rocks and regolith from a distance. So basically, yeah, you can look about 10 feet away. It's like, hey, I don't have to go over there. Is that too hard? No, this uses SuperCam. Yes.
SuperCam, that's what I need. I need a SuperCam. I wanted to point out that I think it was Mountains of Elysium said that Perseverance also has a microphone. So scientists
yes, it does.
listen to the sounds on Mars.
Yes, it does. Where's that comment up?
We love the sounds.
I don't see that comment. Where's that comment?
Oh, it's way up. I'm just going back. It's at I don't know, 2:36 p.m.
That's my time. There it is. Thank you, Mountains. Yes, it does. It does have a microphone. Like my coffin. But it also has a very unique second rover, a helicopter. This is a little image of the Ingenuity helicopter. Yeah, here's a little diagram of what it actually looks like. It's the first helicopter to be flying on Mars. Check this out. This is so cool.
Oh my God, that's so cool. It's like so okay, wait a second. What's the difference between a drone and a helicopter? Is there a difference?
Well, a drone is a small version of a helicopter, a manned helicopter.
Okay, maybe it has to do with like where the driver is.
Yeah.
Yeah. Sorry, I'm trying to move around, and I know I'm making for a little TV here.
Oh, that's okay. Well, I want to show some people exactly where Perseverance is going to be landing.
Yeah. Where?
Right here. Perseverance will be landing right here in Jezero crater.
Awesome.
And here's the interesting thing about Jezero crater. This blue circle that you see on the screen, this is the suggested area of landing. What I mean by suggested area is there is a very unique camera system on Perseverance that will basically is like, hey, what's safe to land? Is this too rocky or is this too soft? It's going to actually choose its own landing site. So this is the proposed area it's going to be in. So they know exactly where it's going to be in the circle right here.
That is so cool. Eastland was wondering if we would hear the wind on Mars. Vile Mike says we're going to find out that Mars sounds like elevator music.
Actually, there is a video that has wind on Mars that NASA released several years ago.
Wind noise, though, is more about the mic than it is about the wind oftentimes. But, oh, look at that. That's cool. What is that?
This is the countdown. Perseverance, sorry. This is the countdown. This is how much it has. 58 minutes, 13 seconds to countdown on Mars.
8 minutes, 58
we got 58 minutes to countdown.
Are we going to, so how much are we going to be able to see here? Oh, Berta Bray says 1 90-second flight per day. Hardly worth it. Okay. Yeah. Okay. So you go wander around Mars for 90 seconds a day and see how well you do.
There right now is a 11-second delay when they get the when they program it, when they get the images and the signals will come back here. So it's kind of difficult because they're going to be flying around. Okay, what is the wind like this time of the day? They have to predict the wind because of the delay. They can also have a huge windstorm, and knock the rover down, the helicopter down. They need to calculate all this stuff before they actually fly it because the Martian atmosphere is so thin. They tested this thing in wind tunnels equivalent to the Martian atmosphere to make sure they actually have a correct pitch and roll for this helicopter so they can actually go places.
Yeah, 90 seconds. You can, I mean, especially with such a thin atmosphere and such a light helicopter drone thing, they should be able to get pretty far in 90 seconds. And I imagine the point of having it in the first place is just being able to like jump to the next place and look at the chemical makeup of the rocks there.
Exactly. They can land it, drop it off here, land it, fly it somewhere else, go back to the rover and charge it, and fly somewhere else. That's the whole point.
That is so cool. That is so cool. Oh, hello. Here comes my brother.
Your brother back.
Yes, my brother who worked at APL, not JPL. Oh, it's here.
Oh,
APL.
APL. That's right. APL. And NASA.
And NASA and NIH and all of the places. Yes.
Yeah, today is the day to occupy Mars, so hey.
Occupy Mars. Oh, this is Elihu. He is, I'll tell everybody, doing an incredible stream for the landing of Perseverance Mars rover.
Ah, right.
It's coming up in just a little bit. Yes. My brother is looking over my shoulder. Ta-da!
Yeah, boy, we did a lot of that going on with the New Horizons thing going on at APL. Which
Yeah.
This is where it was built.
I was watching the New Horizons
He was
on
watching
New Year's
the New
Eve.
Horizons.
On New Year's Eve.
Yeah, that
Eve.
was being broadcast from down the hall from my office at the time.
And I saw Brian, I saw Dr. May come up to the stage and basically give us a little speech of thank you.
All right, I get-
Okay, yeah, I know he had an input on the the camera.
I'll send you a link to this.
Then he released his-
Mary
then he-
Joseph has some good salmon.
Oh, good.
Then he released his song, New Horizons, the premiere video. I'm like,
Oh,
this is so good.
yeah, that's cool. My brother was, when he was at NIH, he worked on the Human Genome Mapping Project, and he got in a band with Francis Collins, who is the head of
Nice.
NIH. Yeah.
I
Yeah,
still want to publicly thank Dr. May for letting me play your video on my show when I talked about New Horizons. Thank you.
Awesome. If you're a science geek, like I am, one of my favorite YouTube channels to watch is Sean Carroll. He's a theoretical physicist at Harvard, Yale, something like that. And he does really, really great videos and live streams. Does ask me anythings and all that kind of stuff. Sean Carroll.
Oh, by the way, will the helicopter fly on Mars? We do not think so. It will. It's designed to be light. The rotor blades are much larger and spin much faster than they would inside a regular helicopter. Yeah.
Aha.
So we think it will be a successful flight.
You know who I expected to see on this stream today was Mars Krell.
Mackerel.
But I haven't seen Mar around today. I don't know if anybody has seen him around.
I am not sure. I
I
mean,
usually see him like every day.
Hmm.
People keep asking Joseph if he has any spoilers since he's an hour, he's many hours ahead in the future. So
yeah, man from the future. Well, what will it only be? Will it be successful? That 7 minutes of hell actually worth it? Yeah, 7 minutes of hell. Come on.
I don't know if people are following the all the drama now about Jedi Bill and the sparkly vampires, but he drama. Jedi says that he is now living on Mars, and that is where he will be for any future showings of the sparkly vampire movies, and that we will be able to hear him from Mars shouting that he will never watch any of them again. Just FYI, these are all the facts. I brought facts to the show, Mars facts. Here's one of them about Jedi Bill.
Well, he also says, tell the mountains, I had a call to NASA about a disaster. Hope you listened. I'm with you now. Thanks, dude. What'd you tell him? The sky crane didn't work? The Perseverance is going to be landing by sky crane, in case anybody's unaware of this. Oh, shit, where's my sky crane at? Hang on. Let me show you a little sky crane here. Where's my sky crane? Let me show you the sky crane animation.
Does it have a robotic arm?
Where's my spy crane animation video? Okay, I should have put it on my little separate, on my own little separate thing here, but oh my gosh. Okay, here. I'll just show you what it's going to look like by this right here.
When people say Mo, they mean mountains of Asia. Oh.
This is Perseverance landing today.
Woo!
Yes, landing soon. No, it's not landing right now. This is an animation of what's going to happen. This is when the parachute releases. It's going so fast. The same speed a parachuter ejects from an airplane. It's the speed it's going when the parachute's landing right now. So what it does is release it with the crane. Sorry, release the parachute. It does a rocket to slow it down to about 300 miles an hour to like 10 seconds, really fast. So it slows down and releases the crane, wires. It's called the skyhook. Then it releases it and jets it off.
Where does it go?
It goes somewhere else.
Why?
Thanks for watching. Please like, share, and
Yeah, this is my friend. Sorry, this is my friend here.
Oh, cool. That's awesome. Where does the sky crane go? The sky hook?
The hook itself, after it detaches, it just flies off. And it pops about maybe 120 yards away at a very safe distance. Yeah.
Okay. So as not to mess up you don't want it to
Correct,
land on the rover. Okay.
Because when it goes down, it's basically the rover's holding the weight of it. When it releases, you got the pressure just boom.
Oink.
This goes off. Yeah. They just
Gotcha.
yeah.
Ah,
It's more effective than the old bouncy ball one.
right. Yeah.
This little guy
Yeah.
had to go through. Come on. Puzzle sojourner.
Joseph says the crane goes 0.3 miles north,
north.
0.3 of a mile north. Yes.
Yeah, thank you.
While Mike says, I'm fairly certain that the helicopter will fly. I mean, Lego made their own version inspired by this, and Lego would not lie to us.
No, why would Lego lie to us? They came up with slippers to prevent you stepping on the Lego pieces.
Did they?
Yes, they did.
Well, I have to say, as a mother, Lego pieces and marbles are like the two worst things that can ever happen to your feet, essentially.
We did not know if Mars was something undetected until now that will keep it from flying. Yes, that's why they need to check all the weather patterns, everything.
Hi, kitty. So this is exciting. So where are they right now? I'm sure you have you have a direct line to NASA, right, Elihu? And you probably have it implanted in your skull. And that's why you have that little antenna that comes out of the back of your head so that you can get NASA's direct feed, right? Yeah.
I thought it was hidden. We have 49 minutes and 21 seconds until touchdown.
All right. Okay. Eastland has a question.
Sorry, 1 second. I was checking out the NASA. Where are you, Eastland? Is it disposable like the carbon tube on the toilet roll? Crane, or will it do things later? It's disposable and will just lay there and sit there. We have a lot of garbage on Mars. And Mars is the only planet that we know that's habitable by robots.
And Vile Mike has something to that effect just above Eastland's comment.
Disposable like the carbon tube on the toilet roll. And when the crane just crashed somewhere after NASA trashing on the planet. Yeah, we leave the trash around everywhere. I mean, our orbital system, we have thousands and thousands of debris surrounding our planet. And there's nobody to clean this up. And there's a chance to impact 1 and 2 every single day. 2 small pieces colliding with each other, making more little small pieces, which is more hazardous for our astronauts out there.
Yes.
I mean, it's okay if those little microscopic pieces that crash into each other burn apart in our atmosphere. We get, 30 tons of dust every single day? So that doesn't matter to us, but that's dangerous to our astronauts up there and to satellites, communication, weather.
And if you think, it's just the astronauts, whatever, just remember, in a very short time, we'll all be astronauts. So, and the longer we keep throwing junk around up there, the more difficult it'll be. It is actually a very serious problem. I know a bunch of physicists who are specifically working on space junk. I mean, because, once you get into those, the sort of the actual careers in physics, they get very specific very quickly.
Yes, there is a very popular nerd that people are familiar with. Her name is Yvette. She's a, I'm not going to mispronounce it. She is a quantum physicist. I don't know why that word eluded me for a second. She's a quantum physicist. She's a very big on axions, neutrons, dark matter, and Doctor Who, by the way.
Yeah, I have a good friend who works for NRL, the Naval Research Lab, and what basically all he does is redirect all the all of the big satellites in space, the government satellites, around projected solar flares. Basically spends all his time, worrying about solar flares.
Yes, CMEs are very, very dangerous.
Yeah. What are we looking at?
This is JPL, Mission Control for Mars Perseverance Landing.
Excellent.
Right now, it is 46 minutes to landing, and they are doing last-minute checks.
Oh, Mar says, I am changing time zones at the moment, but Elihu, who does it again and says something Mars, and I still have no idea Mars. What damn? Finish your sentences. Oh, I said I was expecting Mars Krell on the stream today. That's what I said.
Something, Markrell.
What do you think? So what are they doing? Explain to us what's happening there, Elihu, at JPL right now.
Right now, they are doing last-minute circuit checks because they are so close to the atmosphere. They are getting ready to land, so they're doing last-minute checks, and they're doing EDL starts right now. So, and they're doing they're powering off the LTM computer. The EDL is the emergency download mode, by the way.
The emergency what?
Emergency download. Sorry, I'm used to acronyms. Sorry.
Elihu, tell us a little bit about you and your scientific interests.
I have always been interested in science since I was a little kid. I mean, I couldn't afford any grants or anything like that, didn't qualify, so I study everything by myself. I look at science.
Cool.
I check out NASA, I check out ESA, I check out distant astrophysics researchers, I listen to TED Talks. I do all my own little information here, so whatever I talk about, 99.998% of it is factually based from certified research from NASA, JPL, ESA, different astrophysics, different cosmologists. The only part of that I did have to fake in was the speculation of what happened to Pioneer 10 when the Klingons destroyed it in the Kuiper Belt. So,
Eastland is giving some really good information. She's talking about Perseverance landing itself. That everybody's just kind of watching and monitoring at this point. And Eastland also said that in 2098, they start gathering up the space junk with like a fly netting. Is that true, Eastland? Is this like a real program or is that far off?
That's way far off. Right now, NASA is taking the chance to reinforce the state of the spacecraft so it can survive the landing. This is a safety precaution. They want to make sure it's actually not flipping into orbit as it goes down. They want to make sure it's stabilized at the right angle and degree. So
cool.
Last minute checks. They're Santa Claus right now. They have their list. They check it twice, and they check that list twice. That's NASA.
Joseph says the garbage collecting is a real program, as you were now putting in. Sorry, I keep trying to take over from you. You can tell me to fuck off.
No, if you read the chat, you read the chat. That's why you're up here, right?
Okay. I didn't know why I was up here, so I guess so. Eastland was asking about poop on the moon. And the only thing I know about that is that great movie, Poopy Space Potatoes. Have you seen that?
I heard about that one.
It's got Matt Damon in it. It's called Poopy Space Potatoes. Yes.
I heard about that.
Yeah.
Yeah, there is poop on the moon. And there's urine on the moon.
Humans have been there.
Yes, that's proof. That's proof. We've been there. There's urine and poop on the moon. Our DNA is there.
I wonder if there's barf too. I mean, I would barf, but I guess you'd have to take off your helmet to barf on the moon, but you'd have to take off your suit to poop on the moon. So how do they do it? How do they do it, Elihu?
They have diapers. Astronauts wear diapers during the spacewalks and the moonwalks. So whether they have basically, it wasn't Depends. It was a specialized Depends.
They wear them also when they're stalking their ex-boyfriend's new girlfriends. They also do that. They wear them. They drive them from Texas to Florida. They wear the astronaut diapers. That's a true story. Do you remember that? Were we talking about this? Yeah, there was this. She was on. I don't remember which. She was on one of the ISS missions. I think this. She went a little nuts, and this astronaut based in Houston and was obsessed with this guy who broke up with her and then went with somebody else. And this woman wore astronaut diapers. She was an astronaut and drove from Houston to like Orlando without stopping and tried to like kidnap this woman. They caught her. It was, of course, all of the news stories about it, they all just talked about the astronaut diapers.
Oh my gosh.
Yeah.
I can't believe I forgot his name. I think it was Ed Liu who said his first time he was training, he was nobody told him about the diaper brigade. Basically, it's like, how many times can you poop in a diaper in one day or go on a diaper in one day? This is like an unconfirmed thing that happens in NASA training, okay? Because they teach you how to go to the bathroom in space. They teach you about the suction tunnel for urination for the male and as an adapter for female. And there's a camera that you sit on a training thing. They put a little dot on your butt because the dot has to line up with the camera eye. Otherwise, you're going everywhere. And nobody wants fecal matter in space. Yeah. You train to go to the bathroom in space.
Oh my God. I do remember hearing someone talk about not wanting to go to the bathroom in their diaper and being like encouraged to do so because you can't have that hang up when you're out there on a spacewalk fixing something. You can't be like, I don't really want to go.
That's why they teach them to go when they're in the pool. You go urinate at least. You're in the pool. You're used to it as a kid, right? They want to make sure that they actually do that because they want to make sure the diapers are actually sealing the urine in, not floating around your spacesuits. That's another way to test your equipment. Yeah, you're not just testing out your personal equipment. You're testing out they're testing out the suit, the diapers, and everything in that pool. 80% of training is about liftoff.
Huh.
About 20% of NASA training is the mission. Even if you've been to space several times, you still got to go through the exact same process. Why? You want to go through the exact same process, not mess up.
Yeah. You do not want to, accidentally, let your computer die during your stream or something. You do not want that to happen. Yeah. No ADD people allowed.
Nah. Well, since United Emirates had a probe actually go to Mars, it's the only next time for Elon Musk to send something to Mars.
Wait, what?
EUA, the United Emirates Airways. Sorry about that.
Mm-hmm.
They recently, their probe Hope recently reached Mars. Took some nice colored pictures.
Oh, cool. Oh, one of the NASA guys just said, Godspeed, Perseverance.
Yes.
If you want, I think I can turn it on with audio now if you're interested, but I don't.
I think you can. I think, can you?
They're just, here, hold on.
I know, they're doing last minute chats. Yeah. They are doing last minute chats because we have 38 minutes left. This is the critical stage. I can hear it.
Switches to the auxiliary oscillator. We have also started our real-time data products. And
can you turn the volume down just a hair?
Turn the volume down?
Just a hair. Perfect.
Okay. Yeah, they kind of like get on the line and say a few things and then they pop back off.
Okay, now I just froze up for some reason.
Okay. A man almost drowned on his spacesuit on the International Space Station. Do you know anything about that, Elihu?
Yes, I heard something about that. And I also heard about the cut gloves that they found after a spacewalk.
Ah!
Yes. sorry, before a spacewalk, they inspected spacesuits before and after, and they found cut marks on the gloves. I can't even show you on the gloves. There we go, on the gloves before the astronaut actually went out in spacewalk. So they caught that ahead of time.
Wow.
Yeah, that could have caused a major problem with the brush with the tool and air sealants. Yeah.
As with our tradition, we would have some peanuts at this moment.
What?
We all
Yes.
had our peanuts at lunch.
Yes.
I didn't know about the peanuts.
There's a NASA tradition. He's explaining it.
Keep our tradition.
Yay, NASA JPL people.
Another NASA tradition is when you're going into space, halfway through to the from the room to the rocket, you stop and urinate on the tire.
Yes. I've heard of that one.
Yes. Why? Because Yuri Gregor couldn't hold it; it had to go. So he urinated on the tire halfway through, and it's been tradition ever since. American, Russia, where you go, you urinate halfway through.
Oh, that's funny.
Some NASA traditions.
Yosef wants you to make him a wrench.
Yosef. Oh, where are
Oh,
you,
but
Yosef?
then he retracted it.
Oh.
I
Hit
don't
you with
know.
a
Can I
wrench?
do that?
I was not going to hit you with a wrench, man. I wanted to hit you with a hammer. Come on.
Ah! Bam, bam. What is that we're looking at there?
Oh, sorry. I was trying to get Yosef a wrench for a second. This is JPL. This is Mission Control.
No, we're seeing a big round moon-like thing.
Did the video free? What are
Mission
you looking
Control
at?
Live. Oh, is that mine? No. No, on the screen we're seeing a YouTube feed on the screen.
That's NASA.
Mission Control Live, NASA Lance. Oh, but we aren't seeing JPL, right?
This is JPL.
Okay.
This is the JPL raw footage. This is pure from JPL. The other streams that NASA has, they're cutting back and forth, the scientists and the other people. This is the raw footage from Mission Control head right here. This is them. This is them.
Okay. So they were feeding the thing that looked like, Mars with a picture on it. That was just like a big circle. Okay.
Everything that comes through here, everything that comes through the JPL that you're seeing is coming from JPL itself. This is purely them. I don't know why the thing just got fuzzy for a second.
Yeah.
There it is. Okay.
Well, we want them to use their bandwidth on the rover. So
yes.
There they are.
Okay, now I can see them. Sheesh. Okay, that's better. Yeah, are you making a collection of tools, Yosef? Jedi? Hang on. What are you talking about? Hang on a second. What are you talking about, Yosef? I don't know what Yosef's talking about. He's too much in the future, dude. Rewind. We haven't got to the conversation yet, okay? Man. If you're going to go in the future.
They're saying go flight.
Go flight, go flight, go flight. 33 minutes and 54 seconds.
The computer was having trouble with the visualization and WebEx, but I will restart WebEx and try again.
Oh my God.
Wait, what's wrong with WebEx?
I want to kill WebEx every time I use it.
What's wrong with WebEx?
Ugh.
Probably the last time if you feel the need to do a battery change to do that before we go into quiet mode. Also, unless we have something updated we want to show in the next couple of minutes, we're about to turn over our WebEx screen to telecom for tone. At that point, I'm happy to get updates in chat in our WebEx on EDL ops, but I'd prefer to not have any more callouts over the net unless you see something you do not expect.
Shut up, guys. That's what you just did.
Yeah. And by the way, there is I'm going to show some pictures as soon as the rover's going to take. When it lands, it's going to make public, and I'm going to show those for you guys here since they come out.
Well, this is TAP 3. I have the run-out solution for OD 135, distance to target, 392 meters.
392 meters. We got half hour.
Well, I don't know if people remember when this launched, but it was in
July.
late July, yeah, of the most horrible year on the planet so far, 2020. And it's landing, in a matter of minutes on the side of an ancient river delta in a lake that was once filled, called Jezero Crater.
Yes.
It's going to spend at least a Mars year exploring the landing site region. That is 2 Earth years. Remember, a year is defined by a revolution around the sun. So for Mars, that takes 2 of what it takes us 1 year to do. Very exciting. It's going to be doing some chemical composition analysis, mineralogy. It's going to be doing fine scale element composition analysis of the Martian surface materials. You explained all this a minute ago, but we've got half an hour. This is I'm not vamping. It's the live airtime.
This is based. Sorry, go ahead.
There's the Sherlock Raman spectrometer. See the thing on the screen right now. We're going to be looking at space ramen. We're going to be analyzing whether they use udon noodles or other, whether they use rice noodles or wheat noodles for the ramen through UV gas chromatography. Yeah. Yes.
Basically, yes. I try to make things simple. I try to explain things simplified. I could have gone into all the technical aspects of what the Moscam does, or the Supercam does, or what the RIMFAX does with the radar, how it interacts with the molecule. I could have done that, but I'm like, I would simplify things for everybody. At the end of the show, I'll give links so you can get some specific information, because I can't talk about. If you want more detailed information about the different instruments that are on the rover, I will do that for you guys. No problem. So I try to make things simple. I try to break things down so everybody can understand it. That's why when I have little numbers and calculations, I try to convert them for kilometers. Sometimes I forget for you Europeans, but hey, I try.
Well, you forgot to mention the ramen, and noodles are always like the most important thing in any scenario, especially late at night if you've had too much to drink. It's really important to have your ramen analyzed by gas chromatography. That's important stuff. There is a total of 23 cameras. There are 9 engineering cameras, 7 science, and 7 entry, descending, and landing cameras. And you think your phone is cool?
I know.
Try 23 cameras.
And you mentioned the microphone right here. The microphone's on here.
Actually did, I think.
Yes.
Yeah.
The microphone's located.
Mountains of Elysium.
Oh, thank you, Mountains. The microphone's located right here on the top rover and right on the side.
Cool.
This is where the microphone's located.
The other day. This is
cool.
I still love this rover.
Assembly of the vehicle as we go through.
Okay, so here's a cool thing.
Yes.
You've probably talked about this already. Is the Mach? Can you see the Moxie on there? It's the.
Yes,
this is a incredible experiment where they're taking this small engine to convert carbon dioxide, atmospheric carbon dioxide,
oxygen from the atmosphere. Yes.
So this is like what we're planning for here is our own little space bubbles where we can hang out on the red surface and actually breathe air.
It's not me.
My camera is like, whoa. Because I'm using my phone as a camera and then my phone.
Yes, the Moxie.
The Moxie.
Yes, by Michael Hetch, sorry. From MIT.
So cool.
Sorry, MIT, Massachusetts Institute of Technology. Sorry, guys, acronyms.
Well, and it's just so cool that they're thinking the right way. They're thinking like, we got to live up there, or
hey,
we want to at some point anyway.
As we
I think I got my camera sorted out there.
A lot of members of the EDL team calling out events.
I actually want some hot chocolate right now. But I don't feel like making hot chocolates.
Ooh, I want to do that too.
To give everyone an idea of
28 minutes exactly. 27 minutes, 55 seconds.
Shortly here, we'll get news that the vehicle has separated the cruise stage. Since we no longer need that, we need to prepare for entry into the atmosphere. After that, we will indeed start the entry process. At this point, we're depending on the heat shield to both protect the spacecraft and help slow us down.
Doesn't work. I'm trying it. Joseph?
Gathering data from our Medley sensors, and we'll be decelerating rapidly at that point.
Try it, Joseph.
As we make our way through the atmosphere,
You can hear it, right?
We'll be
Yes, I can hear it. I'm not sure if everybody else can hear it.
thrusters that poke out the back of the back shell.
Let's talk about firing the thrusters. Can anybody in the chat hear that? I want to make sure everybody gets us some great science information.
As we make our way through the atmosphere.
It's going through the atmosphere.
This is one of the things that
Eastland is asking for an explanation of gas chromatography. Well, basically, different gases bounce light in different ways, and so basically, if you shine light through a gas, you can tell by how it's bounced and how excitable the molecules or the element, the atoms in that gas, how excitable they are, and at what wavelengths the light comes back. What's actually in that gas cloud. I believe that is how it worked. Although you asked for an amusing or an accurate answer, I'm not sure that was amusing, and it may have been mostly accurate. But I suggest to you, I've done gas chromatography, and it's just been so long since I've done it that I'm pretty sure I got that right. It's one of the reasons why we can tell what the chemical makeup of a star is from so far away, is because we can analyze. I mean, in that case, we're not shooting lasers at a star,
No,
because that wouldn't work. But we can tell by the difference between how the light comes through the not just space but dust and our atmosphere. We can actually tell the chemical makeup of stars. And it's interesting. One of the things that my hero, my physics hero in this world, is a guy named David Deutsch, who's at Oxford, and he was talking about how one of the remarkable things about Earth and humanity in general is that in most of the rest of the universe that we know of, the known universe, and I'm not talking about posited theoretical universe, but what we know, places are, most places, most planets, most of space, most atmospheres are pretty uniform. There aren't that many different elements and mixed together to make molecules and so on. But on Earth, because of biological processes, and I'm not talking about humans, I'm talking about all of biological processes, starting from the first plasmid, kind of pre single cell organisms, life processes and metabolizes elements in a way that nothing else does. And so we end up with many, many thousands more different kinds of chemical compounds on Earth than you would expect anywhere in space. It's one of the ways that we think that we'll be able to tell that there has been life somewhere is if it has an incredibly varied and diverse just kinds of chemical compounds in a particular place.
Yeah, you don't necessarily need the sun to have life because there's something called extremophiles.
Oh yeah.
Yeah.
And you don't need oxygen, there's cyanobacteria.
No, exactly. I was about to say that. Yes. What are they called? Snotsicles. Snotsicles is a good example of them. Yeah.
Yeah. Like in the heat vents under the ocean and stuff. We do this dumb thing where we say, okay, here's what we know about life, right? Self-replicating, carbon or organic, carbon, nitrogen, oxygen, hydrogen-based, organic, chemical-based, blah, blah, blah. We say, okay, all life must look like that. And then we go look for that. And it's really dumb because actually that's just the way our particular life processes evolved. And it's certainly possible, if not very probable, that life processes could have evolved with totally different, with totally different energy inputs and outputs and chemical, compounds and so on.
Yeah, I mean, there could be some cyanobacteria or some other microbial life around volcanic vents that pierce silver and exhale another chemical. That's it, without oxygen needed whatsoever. I mean, we don't know. Like you said, we're only thinking from a human perspective. This is what we know that causes life.
Yeah. That's why I think it's so important to look at what some some scientists, some physicists are saying, okay, don't just look for X kinds of, animals or whatever, like Eastlyn is saying. Go look for the other kinds of relics, other kinds of things that you find around in systems where there is some living being. And that in this case, we know that they tend to have a much more diverse biochemical makeup because of the very fact of metabolizing anything. Right. Whereas in most places that there is no life, there's nothing to metabolize anything. There's stars, right? There's the Big Bang. There's, sublimation and basic shifting of states of matter, but there isn't the massive intentional biological process of diversification of chemical makeups of things.
Well, scientists do believe there could have been life on Earth because look at the Allen Hills meteorite. When they cut it open and found what looked like a fossilized bacteria. It wasn't on the surface, wasn't on the edge, it was in the center of the rock. They had to cut into it. So they're thinking like, hey, this could not have been contaminated by Earth.
Yeah.
Of course, they say that water is one of the most key relevant things to search for life. And about 50 years ago, people on Earth, even scientists thought, okay, water is very rare in our solar system. No, it's very abundant in our solar system. Liquid water. That's the rarity, yes. Well, we have H2O everywhere. We have H2O on the moon. We have H2O on Mercury. We have several moons that are ice bodies. We have the Plutoids. Dwarf planets like Pluto on the Kuiper Belt. Those are icy bodies. We have comets in the Kuiper Belt. We have the rings around Saturn. That's ice particles. We have water.
Yeah. It's just extraordinarily rare to find it at a steady liquid state, because actually the difference, the spectrum between boiling and freezing, so the solid state and the gaseous state of water, is very small. You can put your finger in freezing water. You can put your finger in boiling water. Don't do it, but you can do it in almost boiling water. It's amazing that most chemicals have a much wider spectrum of temperatures that they are a specific state at. Water just happens to have a very, very narrow one where it's actually a liquid. It's not a solid, ice, or a gas, vapor. So we just happen to be in this very slim. When we talk about ourselves as if we were the end all be all of the universe, we like to say, oh, we just happened to, or God put us on this planet where, there's this very slim sliver of liquid water temperature. And that is a great asset. It's why we think life is dependent on water, because we only know water-based life. But there's no reason why it couldn't be any other liquid.
The HRS vent anchor is complete. We will see the next anchor in approximately 3 minutes.
Oh, good, because we have 19 minutes exactly till landing.
There are currently 12 minutes from entry interface. We are coming upon cruise stage separation in 2 minutes and 20 seconds.
That is step 1. Step 2 is atmospheric entry. Step 3 is peak heating. Step 4 is peak deceleration. Step 5 is parachute deployment. Step 6 is the heat shield separation. Step 7 is the radar lock. Step 8 is the terrain relative navigation solution. Basically, the multi-cameras get to choose which landing site it goes to. Step 9 is the back shell separation. Then step 10 is the power descent. Separation is the rover separation in the sky crane. Step 12, touchdown.
Woo-hoo!
So we have about 85 seconds, sorry, less than 70 seconds till cruise stage separation. Step 1.
Dun, dun, dun.
Dun, 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 dun.
Okay, so this is sort of like when the rocket comes off of the space shuttle.
It's when they separate the outer ring. I forgot what it was called. The casing the landing is in. They separate that in space before it lands out. That's when they separate.
Cool.
11 minutes, 20 seconds from entry interface.
Wow. So it's going to separate like nowish, and then entry interface begins in 11 minutes. We're almost there.
Yes.
I wanted
yes.
to. Go ahead. Yes, CCTV, totally Goldilocks zone. We talked about that. Also, happy birthday. I keep singing to you.
Are received directly from Perseverance, but have very limited information content. We won't receive real-time information.
Fine. There you go.
Birthday to you. Happy birthday to you. Happy birthday to you. Happy birthday to you.
Love it.
Had to.
My kid is texting me, of course.
And by the way, yes, they do keep on changing textbooks because it is more exciting because we always know new information. I mean, before Edwin Hubble, we didn't know that the Milky Way galaxy was all there was. That's all we thought it was. Then he discovered the expanding universe, expanding galaxies. They're moving away from each other. It's like, hey, these things are farther away. That's not a dust cloud in the sky. That's billions and billions and billions of light years away, billions of miles away. Yeah, history changed. My parents grew up, did not know about the function of why the earthquakes happen, the plate tectonics. Going to school, now I learned, I knew. Science changes, science updates everything.
Yes. Karl Popper. He's my man. One of the most, well, I won't get into it, but someday I'm going to talk about global warming and science and the philosophy of the terror of the global warming terror on my cast, but I won't do it now. I won't hijack you.
9 minutes from entry interface.
9 minutes to entry interface. Yes.
So wait, has it separated?
Not yet. I don't think so.
They have said a couple times that
it should have been already.
That there's a pretty, and you said a couple times there was a pretty significant delay in the amount of information that we have.
Yes.
I have confirmation that we got shadowed by the cruise stage as it passed through our beam to the Earth.
If you guys don't know what that means, it was interference from the own rover, from the own craft. They blocked the signal.
Perseverance, entry capsule, and Earth. So we saw a little blip, the data stream indicating cruise stage separation.
Oh, it's separated. Good.
Have confirmation that the vehicle has started warming up those entry thrusters.
Yay! Crew separation completed. Atmosphere entry is in process.
Professor Brainy Specs has some good info there.
The current distance between Earth and Mars, it would take about 11 minutes, 18 seconds for signals to travel back to Mars. You are correct.
Cruise 2 revolutions per minute.
Well, I know it's 11 minutes. I don't know the exact seconds, but thank you.
Desired orientation from.
And when the pictures are released, I'm going to show some.
Separate the two balance maps that has kept it balanced during all of cruise. This will allow the entry capsule to have lift when it enters the atmosphere. We have confirmation that the aircraft has turned to the desired entry attitude. We're about 7.5 minutes from entry interface.
So it has turned to the desired entry attitude. In other words, it's turned itself to be in the right orientation towards the planet for entry. In other words, the heat shields are facing towards the atmosphere.
Yes. Andrea, can you open this tab so I can share this? So I can show everybody this?
Sure.
MRO points carrier lock.
What do you want me to do with it?
Open it up in the tab, or open it up in the tab and hit share screen.
Show it? Okay.
Yes. So I can show everybody exactly what's going on right here.
Screen.
So I don't lose the feed.
Screen. Share screen.
There we go. This is what is going on.
Seconds from entry interface.
Oh.
Let me make it big. Let me make this whole thing big.
They are receiving direct Earth telemetry via that path. The spacecraft Perseverance is currently transmitting heartbeat tones.
Yes.
These tones indicate that Perseverance is operating normally and has nothing significant to report.
What is a heartbeat tone, Elihu?
This is as expected.
The heartbeat tone basically means, hey, I'm okay. Here's my pulsing saying I'm okay. There's nothing wrong. The shaking and the entry is okay. It's not messing with my instruments. It's basically the AOK beeping. It's not a red alert. It's like, hey,
So
I'm doing
where
good.
are we on this? Mm-hmm.
Oh, we are approximately getting ready to go to the atmosphere entry, the second one. Then it'll be the peak heating in a few minutes.
Okay.
That's when I'm checking the heartbeat. It's like, hey, is everything okay? Want to make sure you're okay now.
Just like me. Are you okay? Are you okay?
We're just under, we're about 5.5 minutes.
Thank you, Andrea. I wanted people to know what was going on, so thank you.
Should I leave it up?
Oh, you can leave it up in case I want to go back there.
At that time, Perseverance will be no longer in view of our antennas here on Earth.
No,
About 90
no,
seconds
no.
the Mars Reconnaissance Orbiter should begin receiving telemetry from Perseverance and streaming it to Earth in near real time. There are a few expected short outages, such as when we have a plasma blackout or when we enter the peak heating phase. Aside from these outages caused by the plasma blackout, antenna switching, or high dynamic events, spacecraft events, we should have telemetry until about 90 seconds after landing. A plasma blackout is when the signal from Perseverance isn't strong enough to make it through the superheated, super fast air flowing around the spacecraft all the way down to Earth. Once the temperature drops below that peak heating, we do.
You said Earth. It's going to Mars, not Earth.
We are currently.
It's going to Mars, lady. Wait, it's landing in Atacama Desert? Really?
Where are we? What are you?
She really said Earth. Oh my gosh.
Earth.
Where are you, lady? Are you on Mars? Are you coming sending it home?
That's funny.
Camera reports the electro radio is powered on, ready to receive signals from the lander.
Well, if it does land in the Anaconda Desert, we really wouldn't be able to tell the difference.
That's true. It's probably not happening.
No, if you guys follow Twitter, check out Antonio Paris. He put a side-by-side picture of the Mars territory and him in the desert, and it looks almost exactly like 99.8% exact. So I'm like, hey. No, this is actually in the Martian atmosphere right now, descending onto the surface. So this is not on Earth. This is nowhere near Earth.
It's pretty darn far away.
Yeah. Second spacecraft, Maven, should begin picking up telemetry from Perseverance and will continue to record that telemetry until several minutes post-landing. We won't get that data for several hours after landing as it's being recorded and then will be forwarded to Earth later. We are continuing to receive
9 minutes, 45 seconds.
Everything is nominal. We're currently at about 3 minutes until entry interface.
Yeah, so 9 minutes and 40 seconds till actually touchdown.
Oh my God, it's so close. So
it's in the atmosphere.
We get no pictures, right? All we're going to get is like this data, right?
Yeah, we're going to get the images after it lands. We'll get the images of the descent and everything after it lands. It's not a live feed of the descent, transmitting the descent. No, it's actually stored on a little hard drive. Then it's going to do this little body check, make sure all the instruments are correctly working, like the camera, the microphone. Then we're going to send up upload some pictures. So we'll get those images after it all lands.
Okay.
Yeah.
I want them now.
I want like the Polaroid kid. I want him now, Daddy.
Right, real time, please. Why can't we have our Mars information real time?
Yeah, the urban myth about why the instant Polaroid picture was developed because his daughter wanted to see the picture now.
Oh, is that an urban myth or is it true?
That's what they say at the museum.
Wow,
Urban myth. It's not verified factual evidence of why the film was actually developed, but urban myth.
Yeah. Cool. Okay, man. I need more information.
We're just under 2 minutes from entry interface. As it gets closer to Mars, Perseverance is actually being pulled in by gravity and accelerating. By the time Perseverance reaches entry interface point, she should be going just under 5.4 kilometers per second.
Holy shit.
We're at about 90 seconds from entry interface and standing by for Mars Reconnaissance Orbiter to pick up the telemetry.
8 minutes to touchdown. 8 minutes to touchdown.
How 5.4 kilometers per second is like what? 2 miles per second?
About. I hate not doing my math.
3 miles per second. It's
Uh,
3.3. It's about 3.5 miles per second. I think that's right. That is a fast mofo.
Sheesh. I hate doing mathematical calculations quickly. I hate that.
I just, I live in kilometer land, so it's a little easier if you.
Yeah, I know. That's why I sometimes I forget to convert to the metric system when I'm talking to people. Like, wait a minute, not all Americans are watching this stream here. Oops, there's some Europeans out there. Oops, there's some Australians out there. Oops, there's some Africans out there. Yeah, yeah. It's like because when you study science, they don't tell you the actual feet and miles. No, they give you kilometers, meters, centimeters, and you got to basically like, oh wait, that's 3.5 inches. Okay, yeah, okay.
Joseph says, see, NASA's metric. Yeah, all scientists are metric.
I know. That's why I do my conversions to the American system, because I can understand it. And occasionally I will translate, so hey.
Yeah.
We are about to approach the 7 minutes of hell. Well, we're in the 7 minutes of hell. Shit. 6 minutes, 30 seconds. We're in 7 minutes of hell right now. 7 minutes of terror. Here's it. 7 minutes of terror.
Entry.
We have confirmation of entry.
Oh, shit, wrong button, sorry.
It's currently going 5.3
Sorry, that's the wrong button, yeah.
kilometers per second at an altitude of about 120
Sorry.
kilometers from
Try
the
something.
surface of Mars.
Wow. 120 kilometers from the surface. Atmosphere of entry.
5.3 kilometers per second right now.
The ship is now waiting until it begins feeling the atmosphere of Mars slow it down. Once there is enough atmosphere, it will start controlling its path to the landing target.
Okay.
Indicates entry into the atmosphere.
Good.
Navigation is also confirming that we can see a little bit of that slowdown of the atmosphere on the Perseverance entry capsule.
Every time she clicks, I'm like, what's happening?
It's not me clicking.
6 kilometers per second at an altitude of about 67 kilometers from the surface.
6 kilometers
Ooh,
per second.
67 kilometers from the surface.
I'm pretty good.
You're pretty good at converting the math really fast, aren't you?
I'm pretty good at converting the math when it's one, I'm pretty good at because I live between the two systems. But when it really gets me is when I'm like filling up my car and it's and you're trying to figure out like
Liters,
liters
gallons,
per kilometer. Like instead of miles, like miles per gallon, you get liters
yeah,
per
liters per kilometers.
Like, screw it. I can't do 2 at a time.
Well, a meter is 1 yard and 3.370 inches. Greetings, Adega Outlaw. Welcome.
It's decelerating.
Yes, yes. See this animation right here? This is what they did a few months ago. It's pretty easy to see because we have no live view of the actual descent.
We should play the animation again.
During that peak heating phase, like we call it.
Why? We are exactly 4 minutes and 13 seconds from touchdown. No.
The atmosphere to control.
I think it's 2.2 kilometers per mile, right? Or is that 2?
We are about to hit parachute deployment. The parachute is about to deploy in about 40 seconds or so. Kilometers are shorter than miles. Woohoo! You passed science. Yes, you did.
At an altitude of about 16 kilometers from the surface of Mars. We have entered heading alignment, which means Perseverance is no longer trying to control the distance to Mars, but to the target on Mars, but instead is flying straight to the target.
Yes.
Excellent. And yes, Joseph, 1.6 kilometers per mile, right? I'm thinking 2.2 pounds per kilo. That's what I was thinking. I think that's right.
You know, when Americans say the word kilo, they think of something else. So, hey.
Oh yeah, and Mountains of Elysium. Thank you for repping my nascent feed. Oh my God, we're almost there. I want to see the parachute. I want to see the thing.
You want to see the animated parachute, don't you?
I want to see the animation again.
They're going to show the animated parachute. I saw this video earlier this morning. They're going to show the animated. Don't worry. They'll show what it looks like, what it's supposed to look like.
Okay.
Cameras reporting good telemetry log.
good telemetry lock, everyone.
We are
This means everything's right on target.
We are starting the straighten up and fly right maneuver, where the spacecraft will jettison the entry balance masses in preparation for parachute deploy and to roll over to give the radar a better look at the ground.
There's a parachute. Parachute deployment.
Shoot deploy.
Shoot deploy. Now, the right now, the craft is going the same speed a parachuter exits from a plane. It's still going really, really fast. So the parachute slows it down just slightly, but when the rockets for the enact, it'll slow down even faster. And that'll happen in a few minutes.
It's an incredibly tense moment too. I don't know if you
Yeah.
saw it clapping.
Has slowed to subsonic speeds, and the heat shield has been separated.
Yes, heat shield separation. Next is radar to lock.
Their first look at the surface. Current velocity is 145 meters per second at an altitude of about 9.5 kilometers above the surface.
Now that is a very slow rate. And right now, it's the cameras are choosing where to land exactly right now. They're not going to land exactly directly on. This is the whole unique system. The purpose is like, okay, is this too rocky over here? Is this too soft? It'll choose which spot to land on. This is very, very critical. Very new instrument they're using.
So cool.
Filter converged. Velocity solution 3.3 meters per second.
Yes.
7.4 kilometers.
Now has radar lock on the ground. Current
Yes.
is about 100 meters per second. 6 kilometers above the
You can hear everybody clapping.
Yes. Now they're going to look for the terrain relative navigation solution, where it's going to land. I got the lock.
I'm sharing the screen again of the process if you want to show it.
Of terrain relative navigation.
Oh, that's okay.
Okay. Of the landing engines. Our current velocity is about 90 meters per second at an altitude of 4.2
47, 46, 45 seconds to landing.
We have confirmation that the lander vision system has produced a valid solution.
Yes.
Terrain relative navigation.
Found a place to land.
Good. See, it's not going to find the second one. I love this. No mishap landing here, landing on a rock and busting it open so they can't escape or ruin the rover.
2.6 kilometers from the surface of Mars. We have confirmation that the back shell has separated.
Yes. Yes.
Maneuver.
Power descent.
25 meters per second at an altitude of about 1 kilometer off the surface of Mars.
Please don't crash too hard.
We're on a power descent right now, which means the rover sky separation, the crane will be coming down pretty soon.
Speed is about 30 meters per second, altitude of about 300 meters off the surface.
That is close.
Come on. Separate that rover. Separate that rover.
We have started our constant velocity
Good.
accordion, which means we are conducting the sky crane.
Yes.
Let's conduct the flight crane maneuver.
Sky crane descent.
Wait, they've lost something.
They're about to do rover separation. Sky crane.
Sky crane maneuver has started
About to separate it. After this.
at 20 meters off the surface.
Nominal.
We got about 10 meters left.
Getting signals from MRO.
At 50.
Remain stable.
Rover separation. Sky crane. Touchdown is imminent. Touchdown is imminent. It's being lowered.
Touchdown confirmed.
Yes.
On the surface of Mars. And thinking the sound of past life.
Yes.
Yes.
7 minutes of hell. That is 7 minutes of hell.
Perseverance is continuing to transmit.
Yes.
Man,
Successful
I'll take care
landing.
of her sports anytime, man. This is my sports. Touchdown.
Touchdown. Woohoo.
Oh,
That was
look
good.
at that. I love it when engineers are happy.
Look at the happy nerds. Happy, happy, happy nerds. Happy nerds everywhere.
Happy, happy, joy, joy. Happy, happy, joy, joy.
Now you see they're quickly going back to the stage. Like, oh wait, we're checking them over now.
Right. Yeah. Oh wait, the crane's got to get away. Shit.
Hey, see the guy sitting down. See the guy sitting down in the little row right here. They're checking on, make sure. I was like, oh yeah, my job. How is it? Is it stable? The equipment's running. We got solid transmission already. Yes.
And Professor Brady Specs, I don't care that it happened 12 minutes ago. It doesn't matter. We didn't know about it till now. So there, don't try and spoil our party.
Jeff tried to spoil it, but we told him no.
hug you all now, and run around the room and hug and say, yay! Because it makes me so happy. It really does make me so happy.
It took about 7 months to get there.
God damn, that's a long time.
Yeah.
One, you have what you need?
Flight, we have seen the completion of EDL 3000.
Yeah, the thing is, if this actually take off right now and come back, it'd take 2 years to get here.
So when do we get...
I am refreshing that page right now. I'm going to make
I want pictures.
Nothing yet. No new pictures yet.
Berta Bray saying it's a super spreader event. Yeah, that's for damn sure. We're going to do another whole planet.
Everybody has masks on. Now, by the way, my name is officially on Mars. Yay! I signed that little tag, so my name is officially on Mars.
Yay! Elihu is on Mars. Look! Yay! Oh, the thing is away. The crane is away.
Good. The sky crane. Yes, sky crane ejected. That's the first picture. Oh, where was my? It didn't upload on my thing. Shit! Damn it! It didn't upload on my screen. I want to see the sky crane better. Come on.
When you are ready. We are ready, OL3. Go for it.
Darth Revan. Revan saying, how long before the flat earthers lose their shit? I'm sure they just think this is all staged or something. I don't know why anyone would do that, but
I was supposed to get that image right there as well, and I don't see it on my screen. I'm supposed to get the exact same image, and I don't see it. I'm refreshing it. I'm like, come on.
I have some in JPL. Why can't we have them? No, I'm just joking.
Yeah, I have it right here. But there it is. Jeez. I'm like, where's that? There it is.
It's on the ground. You can see its shadow. Look at that.
Look at that, people. Touchdown.
Yay.
Something's going on with my feed. I'm supposed to get those pictures as well. Shit.
Look at that. I think everybody should clap at home all together now, okay?
Look at that.
Look at
You can see that. You can see that. We can see these flat rocks right there.
Yeah.
So
So
picture.
exciting.
Yeah, you can see the flat rocks.
Just imagine all of the incredible science and future technology and lives and worlds and literature and art that will exist because of this. It makes me so happy.
And one of the... Sorry, what? Was that you?
That was my computer. Ignore it.
Oh, sorry.
You can see we've landed about 35 meters from the nearest rocks that we could identify from orbit by their shadows.
That's the RIMFAX. That's the RIMFAX job.
Copy OL3, TRN in action.
Yes.
And that's the Sherlock's job. First, they're going to use. I think they're going to use the RIMFAX for the radar, for the geological structure of the surface. So they found out if it's either weathered or watered rocks. Those rocks are worn down by weather or water. Then they're going to use the Sherlock because it has a spectrometer with the imaging that can detect components of life. See those rocks right there?
Yeah.
Yeah.
So,
hey, what is that? Something hanging like a baseball bat on a rock?
Well, somebody left their baseball bat out by the canals.
Oh my gosh. So that's a cool little picture. I'm like, what was that? Okay, conspiracy theorist now.
Woohoo!
Celebrate!
Celebrate! You know, like it's 1999. I mean, what?
congratulations, Perseverance team, and the whole team that's not here as well. Excellent job.
Woohoo!
Yay, congratulations, Perseverance team.
Yeah. Woo, 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 woo. You're our superheroes. Real life superheroes.
Superhero.
Yeah, they're all fist pumping and stuff.
Yeah, I would too, man. This is a momentous occasion here.
Absolutely. Oh, it's huge.
I mean, unlike the other rovers, we're not just going to look at the surface. We're going to actually dig into the surface, look at the air composition, and analyze it.
Yes.
We just can't say, okay, this consists of oxygen, phosphane, a little of this, a little of that. Okay, wait, phosphane? Really? We'll actually be able to detect it like we did on Venus.
Yeah.
Not just guess what it is.
Exactly. Mountains of Elysium just just tweeted Marvin the Martian, or just said Marvin the Martian tweeted, "Darn humans, there goes the neighborhood."
Where's
I was
that
like the big
P-38?
furry guy. Doesn't that big furry guy that live up there with Marvin the Martian, where was
The
that
monster.
a monster?
I think that was
Yeah.
the monster, yeah.
Okay, where they shaved him and he was like nothing.
I remember that.
Yeah.
Okay, now what they're doing basically is everybody's doing a little last minute things so they got celebration out of the way. They're testing, like I said, they're testing the rover, getting some more images. They're checking out the microphone, the sensors. They want to check out, make sure the helicopter is actually intact and going to work. So they got a lot of work right here, right now. The past 7 months was basically nail-biting experience for these guys. Now the real job starts, as Michelle Thello says. The real job starts.
Yeah. Yeah. And it's so fascinating how when you get to this point, you look back at the first couple of Mars rovers, which were incredible, but they were mainly, they were almost like an engineering experience. Can we build something that we can land on the planet and move around? What do we need to do to keep it going for a long amount of time? What does it, how hardened does it need to be to survive on the Martian surface? Now that we know all of that, then we get to what you're talking about, Elihu. We're actually going to be able to dig in and not just be like, oh, look, there's a rock, but like, here's the chemical composition of this.
Exactly.
Yeah.
I'm sorry. There's a comment here about can the helicopter clean these solar panels? Technically, if they fly it upside down, it possibly could, but I don't think it'd have enough rotation speed to get rid of the dust. That's what they usually rely on, the winds that clear the solar panels sometimes. I think the ice wars are getting upset with the landings.
Remember when that happened on that movie Poopy Space Potatoes? Do people know what I'm talking about when I talk about Poopy Space Potatoes?
Like I said, that sounds familiar. Poopy, let me see. Poopy. Now I'm going to check this out. Jeez, space. How do you spell potatoes, Al Gore?
You're old.
I know. All I get is Poppy Space Potatoes. It's a recipe.
Poopy Space Potatoes.
Oh, I spelled it wrong. That's why.
It's not actually called Poopy Space Potatoes. It's the one with Matt Damon where he gets stuck and then he has to poop and grow potatoes out of his poop.
Okay, I'm typing in POPPY space potatoes, and I'm getting
POOPY.
Oh, I'm misspelling it. Like I said. Oh.
Don't you guys know
okay. POPP space potatoes recipes. How to grow potatoes, space potatoes. Check potato
Matt Damon
recipe.
gets stuck on another planet. Everybody leaves, and then he has to take poop and grow potatoes in it.
It's called The Martian.
The Martian. Yes, I call it poop space potatoes.
Oh, I'm googling that. I'm like, what the hell is this? Yeah, it's called The Martian. The book and the movie was not realistic because if you see in the beginning of the movie where the rocket's being blown over by the wind, if that was happening on Mars, you would see this.
Yeah,
the rocket would barely move. Yeah, that's how much the wind pressure is on Mars.
There just isn't that much atmosphere.
No. Yeah, I agree with the author. That's the only that part of the movie.
Bird, it was Dan Quayle.
Oh, sorry, I thought it was Al Gore. Thank you.
Nope, it was Dan Quayle.
Thank you.
Need the river to dance and shake like a dog to clear its solar panels. The river to dance?
What is the river? River song?
I don't know. Maybe she likes river dance.
Amy? Who knows?
Amy? Did you say Amy? Who is Eastland? I love the name Eastland. What a lovely name.
Eastland Burkholder, yeah. Eastland rocks.
I think so too. Yeah. I haven't totally interacted with Eastland on a live kind of way. The rover, not the river. Oh, yes. The river. The rover needs to dance and shake like a dog.
You said the river. I'm like, river song?
No, Dan Quayle spelled potato with an E on the end, I think, right?
Yes.
And it only has that E when it's ES. Is that right? Or is it tomato? I get them mixed up.
Potato, tomato, list, Milano, all same thing.
Let's eat the old things off. Okay, autocorrect will not let us type rover.
It will not.
Tab 2.
Probably doesn't like the word.
Rover. Huh. Interesting.
Well, so what do we do now? Are we waiting for pictures, Elihu?
Well, they already got the pictures here. The Perseverance has made it to Mars. So. And they're just basically doing last minute checks and checking out the rover itself. And my images are not coming through. I was going to try to show you some of these raw images, but they're not coming through for some reason. And I apologize for that.
There you go. I turned off the stream from
NASA.
NASA.
Thank you. Yeah, the audio, right?
Yeah, the audio. Yeah.
Autocorrect not let type rover. That's weird. It'll let me type it. See?
Well, so Elihu, I
well,
wonder when we get actually, are we ever going to get like video of the landing?
No.
I mean, obviously not from a third person point of view or a third robot point of view.
No,
but...
what's going to happen when we get the images? We'll get the descent images down like we did when the probe landed on Titan. We'll get those images going down. Somebody's going to end up compiling them together into a video, so it'll be easier to see. But we'll get the first images going down. Then there'll be some large, high-def images after they get the clinical resolution from the actual landing Perseverance itself on when it actually landed. That's the small image that we got on the screen. I was supposed to get that image, and this still upsets me. I can't even get my raw images. I don't know what's going on here.
Well,
it's constantly. It's right now. The rover's beaming back the images from the landing, so we're not going to get those for a bit. The public is not going to get those for a bit, unless they show them on the GPL or NASA site. But we will get some information about some of these tests, maybe in about a month or so. We'll actually have some little preliminary results of what they found. Especially those two rocks look interesting.
Yeah.
One was flat, one with a little arc. Yeah. Was that arc from wind or from water?
And Will, that's exactly what they're going to do. They're going to start from where they are, and they go like
exactly. Like, hey, look at that rock. What's that arc right there? Wind or water? What's that first one? Is that water? It's flat.
So cool. So cool. I love it.
They think that the crater was an ancient riverbed. So,
and it was full of water, like literally. Yeah.
Yes. And they're going to dig into it.
Yeah.
Okay, hey, I want to thank everybody here for joining me today, especially Andrea. Thank you for being a little co-host.
Wait, I'm going the wrong way.
You forgot where I was, huh?
I'm not used to this yet. I'm like a bad weatherman.
The Weatherman, yeah, that's a good movie. Oh, hey, Andrea, you have a rent, so why don't you put your little information in the chat here so people can follow you and subscribe to your channel. And you guys can check out Andrea. She rants. She raves.
I don't. Do I rant? I don't rant.
No, the ranting is a little funny comment. Everybody rants. So she talks. She chats with you. She laughs.
I have 45 subscribers. It's very exciting.
Ooh, 45.
Yeah.
I'm looking at something right now. Hang on, sorry.
I put it in the channel.
Thank you. So everybody, check out Andrea. She's funny. She's informative.
I want to get to 100 subs, because
yes, we need to get her to 100 subs. Click, subscribe, share.
I guess I have to think about what I'm gonna do if I get to 100 subs. A la Jedi Bill, but I'll think about it.
Maybe. Okay, I want to thank everybody for joining me and thank Andrea. And hey, next week, I'm going to try to get some little updates on what I found out about Mars and Perseverance, some more pictures and more science stuff. It's more sciencey fun stuff. News, yay! And also next week on the 24th, this is going to be another show. Wednesday, back to our normal time. Wednesday, 12 noon Pacifically, specifically at 12 noon. We're going to ask what's up with the universe called impacts. Since we're at a crater right now, we're going to talk about the many impacts in our solar system. What they've had, where they happened, when they happened, the impacts they had on the planetary surface, and possible in the future. And I'm going to give you a spoiler. The chances of a huge asteroid striking Earth that'll wipe out humanity is 100%.
Yes.
That is the actual odds, 100%. but we don't know when. So I'll spoil that.
Humanity may not exist by then, but
Okay, I want to thank everybody.
moment as if that it just landed on the planet, except it's you and your stream that landed, and so we all get to jump up and clap.
Jump,
and
jump for joy, jump in, yay! Sorry, 1 second. I'm trying to find something real fast. Okay.
I'm learning.
You're learning? Yeah, I'm this way. No, I'm that way. Well, like I said, I'm everywhere and nowhere at the same time. And Andrea, if you have a Twitter, you tweet. Put your Twitter in there so people can find you.
Oh, Radio Babe.
Type it in. People have a hard time spelling and getting worse. Some people spell phonetically. Some people spell actually correctly. So please do that for other people. That's why I try to talk clearly and have closed caption on this show for a rewatch. Anybody's rewatching, there's a closed caption. So sorry, I can see it. Did you do that yet?
I did. I'm Radio Babe. On
Awesome sauce. Okay, thank you everybody for showing up. Have a good day. I cannot play my exit because I can't get the load correctly. Oh my gosh, this is weird. Those damn mice. I have these little anonymouses. They sometimes try to sneak in everywhere, every once in a while. And right now they mess with my program. I guess they don't want to be seen, so hey.
They eat the chocolate by the side of my bed every night. It's a big
chocolate?
Problem. Yeah.
Chocolate?
Yeah. I put chocolates by the side of my bed, and when I wake up in the morning, they're gone. It's terrible.
I think it's either the kids or me. Wait, I don't live near you, so never mind. Okay. Thank you everybody for coming here. And I will see everybody next week, either on a rewatch or live. Later, people.
Bye.